Yeah, we're live. As you can see, no green screen. I've moved it out of the way. I just got tired of moving it around. So it's going to give me incentive to get all the green screen effects get going for that's one of my projects for this month. I want to get that, and I want to get some t-shirts going too. So I have a list of things I want to get going, and those are all on it. But tonight, where I'm here even early, a couple minutes. Tonight we're going to talk about a couple things. One, the thumbnail that I have up is the famous or now infamous, I guess, LS4 5.3 liter that's in the front wheel drive applications in various different kinds of cars, Monte Carlos, GXPs, and things. And this is the first time I put the video up today. Hopefully, you guys have all watched that. I put the video up today comparing that intake manifold compared to the factory truck manifold. And before that, if you take a look at the video that I have up where we tested a bunch of cathedral port ones, I say all of them. At the time, I think it was all of them, but it's not. It's certainly not, obviously, because I didn't have the LS4 intake manifold. But if you take a look at that, the low man on the totem pole before that was the early original, the OG 5.7 liter LS1 intake manifold. Then they replaced that with the LS6 intake manifold that came only on the LS6. And then I think that they installed that same intake, the LS6, and we're just making that and put that on all the LS1s as well. It's a much better intake manifold than the LS1, as that shows you. There is a pretty good gain from just the LS6 manifold, but also the truck manifold is better than the LS1. The LS2 is better than everything's better than the LS1. And I thought that for a long time, especially based on that testing, that and we know all the aftermarket stuff is really good. The Fast, the LSXR, the LSXRT, even the original Wilson Fast is quite a bit better than obviously the original LS1, and then all the Holley stuff, the high Rams, and even the single planes and dual planes and all that stuff. So in that test, I thought, well, that guy's still kind of the low man on the totem pole. But now, having tested this LS4, people have been telling me, "Hey, have you ever tested that?" I'm like, nah, I've only ever seen one of them in the wrecking yard, and I should have grabbed it because it had 243 heads on it. Also, it would have had this intake manifold that I could have tested, but somebody sent me one of these way back. I'm sure I've probably had this intake. I'm thinking it's a year or two. So whoever has sent this to me, please let me know. I think that their information is on the box, so I can send it back to them if they still want that intake manifold. Maybe they don't want it after the results. But that intake compared to the truck manifold, the early truck manifold, not even a Trailblazer SS, just the early truck manifold, was down 58 horsepower. Like I said in the video, I thought something was wrong with the motor. I thought when we did the intake swap, which is not terribly complicated on an LS, but I thought when we did the intake swap, I left off a coil bank, or at least one coil or a plug wire or something to make it be down that far. But we went in and checked everything, and everything seemed to be running right. The air fuel seemed to be right. The timing seemed to be right. I even did an ABA test and took that manifold off and put the truck manifold back on, and boom, all the power's right back. It's like, hey, this is what it's like to actually be able to breathe. So unless I take that manifold apart and find rag stuffed in there or something, these are kind of the results. And I was very, very surprised that a manifold could be that far down from another one. Now, we know I showed in the video a comparison, for instance, between the stock LS1 manifold and the truck manifold, and then the fast manifold. And the fast manifold compared to the LS1 manifold is up by like 56 horsepower. But that's on a nearly 600 horsepower 6-liter LS. So the difference there wouldn't even be that great. It still didn't reach the difference that we saw on the LS4, but it wouldn't be that great on a much milder combination, because we tested the LS4 versus the truck manifold on about 480 horsepower or so, 5.7 liter. So the difference on even with a fast and an LS1 would be way less than that. So it's amazing that it's that far off. But that was the test, and it was a good test. I'm glad I finally got to test it, because a lot of guys have wondered how far off is that. And it tells them, at least for the LS4 guys, the LS4 guys that have money to put into a new transmission, it tells them that there's lots of power to be had if you can put a better manifold on there. And I think haven't seen one of those, or I haven't worked on one actually in the car. So I think that there are some limitations in terms of where some sensors are, and obviously the hood height and accessory drives where the throttle body has to go and that sort of stuff. So I think that it's not just a matter of taking a fast and putting it on there. I don't know if that's just an easy possibility. If it was, that's the way that I would go. Or at the very least, an LS6 or a Dorman LS2 or any of those things that are going to be a big upgrade from what's there. Because even if an LS1 intake manifold is a big upgrade from the LS4, everything else is going to be a giant leap up above it. So you can pick up a lot of power from that, which is kind of nice to know. They also have some other differences with the spacing on the, they have the accessories really tucked into the motor and stuff, again, so that it fits in that platform. But that's interesting stuff on the LS4. So I'm glad I got to test that manifold. Now the next manifold for me for LS stuff on my list to test is I would like to test the a ported version of like the LS3 manifold versus I want to see an LS3 because a fast manifold compared to an LS3 doesn't really do much compared to the stock LS3. So I'd like to see a modified version of a ported one that actually does something. I'd like to see 10 or 20 horsepower from a modified one, and all without losing power somewhere else. Because we can get that kind of power gain, as we saw in the LS3 intake video that I have up. We can pick up power up top, but it's almost always accompanied by a trade-off. The one exception is the Cross-Ram Edelbrock manifold that seemed to make a good bit of power everywhere, even compared to the factory one. And so that did well. But a lot of guys don't want it looks really good. It makes the LS look like a Ferrari engine, which is awesome. And dual throttle bodies is cool. But again, do guys want to go to the trouble of syncing 2 drive-by-wire throttle bodies? Maybe that wouldn't be that big a deal. I put manual throttle bodies on it to run on the dyno, which is very simple. Also, that manifold is very heavy. And I don't know if Holley might make it now an LS3 version. When I tested the Holley version on the cathedral port heads, there wasn't an LS3 version of that, but there might be now. And their fabricated sheet metal or aluminum, whatever it is quite a bit lighter than the Edelbrock was. It doesn't look quite as good, in my opinion, but I do like the way that they perform. They worked very well. The other thing that I want to talk about is this right here. You can see, look at this. Wop, 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 wop. You get to make the noise and everything. This one, as you can see with the zip tied, this one's wired open rather. This is the Magnesium FR500 intake manifold. So here's the lid for it. You can see has the dual throttle body inlets, just a kind of lid. This is the one that we were running on the engine dyno, and then I did what I did on the video on the 3800 too. We were running it and went to wide open throttle and then just pulled this off with these opened up all the way like this. And so basically it just made it into an IR deal, because what these do is this is a dual runner manifold. So with these closed, it breathes through the long runner. And then what opening this does is basically cut the runner length in half and allows the runner just to breathe directly from this right into the port. So then all of a sudden you have about this much runner length, but whatever that is, 6 inches or something like that, versus having it to crisscross all the way, because there's another lid or bottom, a plenum cover basically for the bottom where the long runners would breathe from. It's pretty cool stuff. And over here we have this. You can see this right here. See that opening back there? That's where all the airflow goes once it comes in from the throttle body. So the reason I bring this up is somebody needs to make me an offer on this. I need this. Just been sitting around for years and years and years. So I need to sell this. So somebody out there that has a 4.6 4-valve motor needs to make me an offer. Like I said, it's Magnesium. It's a Ford racing piece. It's a dual runner intake. I do not have the actuators. There are cables. The cables I think you can get from the Aviator maybe, but I don't have the controller that actuates these. So you'd have to do that yourself. They're very expensive manifolds, but somebody make me a good offer on it and then let me know, and then we'll work something out. So that's that. So the next thing I want to talk about really quickly before we get into answering the questions and stuff is that the next video I'm working on, this will be for tomorrow, is I want to talk about why oftentimes the big bang motors that I do are able to exceed the power boost formula. And that is the fact that the power boost formula simply states that if we have a 300 horsepower motor and we add 14.7 pounds of boost from a turbo to it, the 300 horsepower motor will be transformed magically through the wonder of boost to a 600 horsepower motor. So basically you double the power output when you add another atmosphere of pressure from the turbo. because your motor is running under atmospheric pressure when it's naturally aspirated, and you add another atmosphere, you double the horsepower, and then you add another atmosphere, and then you triple the horsepower, and that's how the math works. Oftentimes, we don't get that, especially on pump gas. You're hardly ever going to get that on pump gas. One, you need really good intercooling, which is very important. You need enough octane to run the timing that you need to make the power that you need, that combination can make at any given boost level. If you don't have the octane, you can't do that. So you need the octane, and you need the right size turbo to work in the effective power range that you're looking at. So if you have a 500 horsepower turbo and you're trying to make 600 horsepower, obviously that's not going to work out very well. So having more turbo is better, because if you have a 400 horsepower motor and you're trying to make 800 at 14.7 pounds of boost, and you have 1,000 horsepower turbo, chances are you're not going to have a lot of back pressure with that. So that's the other issue, is if you are just trying to eke it out right at the end, and if you're at the absolute flow limit of either the hot side or the cold side of the turbo, it's really hard to do that formula. The reason why the big bang stuff usually does well, there are multiple reasons. One, if you take a look at like the last two that we ran, the 2 6-liters and the big block, which hasn't been completed yet. But if you look at those, you see that we over turboed these combinations. And we did that for a couple of good reasons. One is that having more turbo means that these turbos are going to be running in their sweet spot. So if we're looking at, in the case of the 6-liter, we're looking at 1,500 horsepower. We have 2,000 horsepower with the turbo because we had 2 S475s on it. We're not going to be anywhere near either surge, obviously, or we're not going to be anywhere near having lots and lots of back pressure, or the flow limit of the cold side of the turbo either, because we still have 500 horsepower worth of flow potential to play with. So we have low inlet temperatures going in based on the boost level, because it's in a fairly efficient part of the island. We don't have a high back pressure. All of that's good. The other thing that happens is, let's see, we have enough. We have enough flow. The other thing that happens is on these big bang motors, along with having enough turbo, we have more than enough intercooler also. And the intercooler is very important. And this is where we step our game up on the big bang stuff, is that we run ice water. And so that's why one of the reasons why we get better than the formula numbers is because we're cooling the charge temperature down dramatically. The NA motor, if we use that as a comparison, and let's say our NA motor is making 500 horsepower, and then we more than double that. So we were over 1,000 horsepower at 14.7 pounds on our big bang motors. And the reason for that is because the NA motor didn't benefit from having ice cold water cooling the ambient air, but our turbo motor does. So we picked up quite a bit of power. So I'm going to show you how much power we picked up going from regular water, which is already very cold because the dyno has a 2,500 gallon cell that we use to feed our intercoolers. And then the hotter it is, the better having an unlimited source of cold water is. So it's already pretty good, but with ice water, if you have a 32-degree transfer medium, it gets really good. The thing that would help our setup is, especially at the 1,500 horsepower level, I'd like to have a lot more water flow through the core. They just go in and back out the same area. I'd like to have them both as ins, put dual outs on the other side, and have it just flow through to get maximum flow through the core. But that's something we might investigate later on if we run these other, the big bang, like big block, for instance, or we do another LS or whatever we would do that have big twins on it, where we'd be making lots of power. So that's one of the reasons is ice water helps us improve beyond the formula a lot. The other thing that can help us do that, and I honestly have not tried this, and I wanted to get your guys' opinion on this, so let me know in the comments, is I've not run E85 on any of the big bang motors. When we run the big bang motors, we're normally running fairly high boost levels, for instance, as high as 29 pounds on one of them, before something and nothing even broke. We just ran out of map sensor. So running 29 pounds, I've not run that sort of boost level on E85. So if you guys have, or know people that have racers or whatever, let me know in the comments if you guys have run 29 or 30 or 35 pounds on E85. Have you done that? Because the other thing that we're doing that I might try differently in upcoming big bang motors is I'm fairly aggressive on the timing. So even at 29 pounds, we were running about 18 degrees of timing, which is probably a pretty good amount. But we were running, we weren't running E85, we were running 118 race gas, and we're running ice water through our air to water intercooler, and we have turbos that are fairly efficient going into that. So we have a lot of things going for us. The run is fairly short. I didn't, in the case of the Big Bang stuff, I did not have the turbos hooked up so that they were referenced with RPM, which is something also we're going to do in the future on future Big Bangs, so that we can hopefully limit some of the torque production. Because on the Big Bang where we made 1540, we had 1,330 or so foot-pounds of torque. And that's a lot for a stock rod. As we found out in the Gen 3 Big Bang, it turned out to probably be too much. Although again, you just don't know with these junkyard motors what their life was like before that, and you know, it's hard to know. Do I have a really good example of a junkyard motor? Is this an average example? Is this a bad example? Was the thing already overheated a bunch? You just don't know any of that stuff when you take it apart and then put it to get back together and say, okay, are you ready now for 29 pounds? So having the combination, I would like to try E85, because if we have E85 and we have ice water, I think it's kind of the double whammy for Big Bang stuff. And I certainly would like to try that. I think that I would like to try that on the 3800. So if we have that and ice water, and we have an oversized intercooler anyway because the intercooler that we'll be using is going to be sized that will easily support whatever kind of power level we might make on the 3800. I really have my fingers crossed. I really want to make 1,000 horsepower with that thing. And I'm hoping that we can. But if we do, it's going to take 30-ish or so pounds of boost. So my questions are twofold for that. And also for other Big Bang stuff. Should I try that on E85? And have you guys tried that on E85? Have you done, 29 or 30, 35, 40 pounds of boost on E85? Have you done that on any kind of application? And also, if we do that, do we think that I should, if we're adding boost at that kind of level, should I start backing away on the aggressive timing also? So if we go up to that kind of boost level, so I should start retarding the timing more. So instead of running 18 degrees, for instance, like we ran 20 on some of the LS things. Even at 24, 25 pounds, we were at 20 degrees of timing. But again, we're very cold on the ice water and stuff. But I'm wondering if maybe we wouldn't benefit from keep going up in boost, but come down in timing more. Strip it down to 16 or 14 or something like that. I don't know how much. We know. The thing is, if I come down in timing, I know we'll live, at least in terms of not detonating because of the timing. But what it also does is not make very much power, because I've run tests where we've run, we've run timing steps on it. So here's what it does at 22 degrees, and then 20 and 18, 16, all the way down to, we may have gone as low as 12 or something. And at 12 degrees, it makes very little power. I mean, it might be down 100 horsepower compared to running the right amount of timing. And so I'm wondering how much we lose with the timing and then how much we gain with boost. Is it a net gain if we add up there, if we add 2 pounds of boost and drop 2 degrees of timing, is that still a net gain up in those higher boost levels? There's guys out there that drag race, I'm sure, that know that, but I've never tried any of that, especially at those higher boost levels. So let me know what you guys think. And I think the thing that's going to help us a lot with this thing is if we can make it a rising boost curve on the 3800, for instance, and even more so than the 3800 on the big block Chevy. It needs to have a rising boost curve on the big block, because on the big block right now, even with those turbos, which are oversized, which soften the spool up, that thing's still making as much torque as it does horsepower, and we do not want it to do that. If it's making 1,500 horsepower, which I don't know if it will get there, we don't want it to make 1,500 foot-pounds, because it's making peak power at like 55 or 5,600 RPM or something. We need it to make power much higher. So those are the things that we're kind of going through. But I'm excited about it. I'm excited about running the Big Bangs on all those. We don't have to worry about it that nearly as much on the K24 Honda, because it's making peak power much higher than it's making torque. So it's making, for instance, when we were running 620 or 630 or whatever we ran it up to, when I was over with the guys at Skunk, we were not running very much boost. I think it was 12 or 13 pounds or something. And we were running that power level, but I think we were only making 400 or 450 foot-pounds or something. So it was much better combination because it makes power at a fairly high RPM. Not like a K20, but you know, the K24 is still the big block of the of the K series motors. But it's a much better situation, much better than the 454 is. That's kind of the worst example that we have now. And we probably would see that the same thing when I add boost to the 460, although I'm not planning on doing a big bang right now for the 460. So that's my discussion for tonight. Let's see what you guys got. Oh, that's right, Michael. I forgot about that. I do have to do the chili bomb test too. So before we run because I'll run boost levels on. I also want to run on the 3800 particularly, and we might do this on the 48 or something else. I want to run a bunch of different turbos on it, and the 3800 would be a good one to do that. I want to run the 3076, the from the Max Speeding guys. We want to run the 3076 and the 3582. And then they gave me a bigger one, which I think is like a GT45. We'll run the GT45, obviously. And then we can run a 7875, like the deal from Byron, the VS Racing deal, the Gen 2. And so I can show you, hey, look, here's what the steps up did for boost response, even though an engine dyno is not ideal for that. But we can get an idea on how they work and how much better one is than the other, because obviously the smaller ones would be good. And if we run them all, like I'm thinking that the 3076 certainly should be a 500 horsepower turbo and might be a little more of that. The GT3582 is definitely going to be a 600 or maybe a little bit more, maybe. We'll have to see, but that will be interesting to see what power level we run those at. So let's see what you guys got. Maybe use the chili dog to cool the fuel. Chili bomb. Let's see. The LS4 intake throat pinches down to 30 millimeters. That would be pretty small. The chili bomb definitely needs to be tested, and so that would be one of the other ones that I would test on the 3800 probably. Would you put short runner inserts on the 3800 to kill torque? We did that test. That test is up. We compared the short runner stuff to the long runner stuff. Probably I will go with some version of the factory blower intake manifold because it's even shorter and kills even more torque. But I'm thinking about doing my own plenum for that, or at least making the throttle inlet go into the big plate. I made 750 on 238. I don't know what 2.0 3800 will be no problem in 1,000. I don't think that 1,000 horsepower on a stock bottom end 3800 has ever been done. So I'd like to see if it could be. Still waiting on 351 Big Bang retest. I love it. I'd love a bunch of 3800 turbos test size. I would too. And I ran a bunch of those on the K24 and it worked out pretty well. And the 3800 will have MLS gaskets and head studs on it. If the ported heads work out the way that I think that they do, they should flow 230 or something. And if this motor makes 300 NA, that will be more than enough to get to 1,000 horsepower in terms of the power output. It would go way more than that if we just keep pumping boost into it. I'm not worried about it making the power. It can easily make 1,000 horsepower. We have enough turbo to do that, and it would make 12 or 1,300 or 1,500 if we keep turning the boost up. The thing is, what will it break? Will it break something before we get to the 1,000 horsepower mark? Will it break a rod or a piston? Because that's what's going to let go. Michael, you're considering those two turbos, the GT3076 or the GT3582. If you're putting two, are you running a V8 BMW, like a 4-liter V8 or something? Corn-Fed Boost YouTube channel is running an L67 with 30 pounds on an S400. S400, that should be 30 pounds. Seems like a lot on that with that turbo. How big were the injectors on the Gen 4 6-liter? The one that made 1,500 had They were 120s, I think. What's better for the small block Chevy Street, the Performer air gap? I didn't know that there was a Performer air gap. The RPM air gap is usually my choice if you're especially if you have a good decent sized cam in it, like a 224 cam in it. Need to revisit your blow through stuff. You're struggling. Run 7.8 air fuel mixture. I'm sure that that's must be an E85 number. 16 degrees of timing at 26 pounds. The 3582 should do more than 500, I think. There are L67s out there making 800 at the tire with a stock bottom end. Can you test the Camaro Firebird 3800? I didn't have one when I ran this test. Does there come a point where once head flow is maxed, say in the thousands, could a head with bigger port but less flow make more power? I don't know. I've never seen any kind of test like that. I think that the flow, I don't know if you can get to your question kind of is volume versus flow, but I don't know if you get to a volume problem. See, where is the injector is injected into the head? I don't know. I don't know as an absolute for that. Head scam intake LS1, recommend a ring gap for 150 shot. You might not need to do anything. I've run those kinds of shots on unknown ring gap before. Otherwise, if you're going to take it apart and ring gap it, I would put like 28 or something in it. 3-liter 6-cylinder of BMW. And if your target is 400 wheel horsepower, you need to put the 3076s on it. And more than likely, you could put one GT45 on it and do that. I wonder if there's any way to chill boosted air other than dumping ice in a reservoir. Yeah, guys do the Freon deal. Just guide air, any special features or caveats of the LS4? It's not the same. It's the same as a 5.3 liter. There are subtle differences. Obviously, the intake manifold flows a lot less and makes a lot less power because that video I just put up. And the accessory packaging is way tighter. I think that maybe the crank flange is a little bit different, I thought somebody said. And as I just posted on Instagram, also I think on some of them, the front cover is different too. The position of the cam sensor is different. Jeff, I dumped the B303 and got the Extreme Energy 274 for a single turbo 5-liter Ranger. I think that the 274 should make more power than the B303. Richard, was your head on Dave Advisor's YouTube video? Yeah, they did the port molding. I don't know if he's done anything else with it. The LS4 also has the V6 flex plate because it's smaller diameter, right? Because it has a smaller bell housing. Any chance you could run the truck Norris cam on a larger displacement to compare that to a big block torque curve? If the displacement is more on a bigger motor, it's going to make more low speed power. The most I've ever run on unknown ring gap, and we fully expected to break the motors. I had a 5.3 that we got from the wrecking yard when I did the shootout with Chris Kamikaze from somebody tell me what the name of the drag race program is on Discovery. They're all from Oklahoma. I can't even remember the name of it. But anyway, he came out and we did a shootout with 2 identical motors, and we ran 300 shots. We just topped out the plate systems that we had, and I never took the motor apart to figure out what the ring gap was. And we ran, 20 degrees of timing and 300 shots on it, and hope for the best. I remember we ran a Big Bang Gen 3, ran ported 317s, and the Gen 4 ran trick flows, and the Gen 3 was doing very well. They all make good power, yeah. The LS1 heads are about the worst. LS heads, they made a little more power than the 317s did, only because they have a little bit higher compression. Street Outlaws, that's what I was thinking. I know I couldn't think of that. Richard, do you recommend Holley Sniper EFI? See, when people ask me about sniper stuff, I don't ever know what they're talking about. The sniper name, they apply to 1,500 different products. So I don't know what it is. They make a sniper EFI intake manifold. As a matter of fact, they make many, many of those. And so are you talking about the EFI ECU, or are you talking about the 4-hole throttle body thing? I don't usually recommend those. I recommend a carburetor more. Dan, you're not late. Street Outlaws, that's what. Yeah. Finally, where were you guys? I guess I hadn't scrolled down yet. Farm Truck and Asian, I like what is it? The Lamboni, is that what it is? The Lamborghini. What do you think about the sheet metal intake manifolds? If you're talking about the sniper style fabricated ones, all of those videos are up and show you exactly what they do. That manifold loses power up to 6,000 or more compared to any of the long runner manifolds, and never makes as much as a fast does. David Visor said you lose 20 horsepower with a 303 cam. Compared to what? Not compared to a stock cam. 1,500. I've told you 1,000 times not to exaggerate. It wasn't 1,500. It was 1,543. So I don't. What's the opposite of exaggerate? Really need to talk about the LS6 heads and intake. Make 40 horsepower for way less than a fast intake. So you can get LS6 heads and an LS6 intake manifold for less than the cost of a fast? But what if you already have LS6 heads? A fast still makes more power than an LS6 intake. Whether or not you want to spend the money on it, that's up to you. But the fast intake always makes more power than an LS6 does. Have you ever run any of your subscriber stuff on the dyno, like a motor or a blow-through carb? No, I haven't. You're going to want 1500 cc injectors for E85 on a 6-cylinder if you want to make a lot of power. Not sure if you answered this already, but will the 3800 intake from the F body be run on testing? I wanted to when I ran the testing before, but I wasn't able to get one, so probably not. I wish we would have had one when I ran all that testing. Juan, if you've got 799 heads and you have the Trailblazer SS or the NBS, whatever people are calling that intake manifold, you're fine. You're not going to pick up anything with an LS6 intake manifold. The only thing you would pick up is fitment. The cool thing is if on that 5.7, Utah said, yeah, what's up, guys? That Iron 5.7 was cool, and the intake tests kind of want one with that kind of power. The cool thing is if you run that sloppy best cam, shout out to Matt, if you run that on that motor, it has good heads on it. If you put a fast on it, that thing's going to be over 500 horsepower, which is quite a bit. I mean, which would be a really good street motor. You run 2200 cc injectors with E85. Yeah, we would definitely need more injector than I've been running with gas. Would 70 psi injectors? Well, they wouldn't be 70 psi. They would be 70 pounds. Oh, pounds per square? No, they'd be pounds an hour. Injectors be too much? No, that would be fine. You're gonna have to tune it, but it would be fine. I don't have time to test it. I don't have that motor in a configuration where I can run that 3800 intake. Where the next thing we're going to be doing is it's going to come all apart and be machined. We're going to surface the deck so that we can use MLS head gaskets. We're going to put a bigger camshaft in it, hopefully ported heads from Eric, and then we're going to start running boost on it. A 303 cam can make 300 wheel horsepower with how much boost? Also, I'm running a 228 cam. That's would not be my choice. I would rather run a dual pattern cam. So is it fair saying the fast intake is a horsepower multiplier rather than 14 horsepower it adds? Well, it depends on I don't know what 14 horsepower you're saying that it adds to. The amount of power gain that you get from a fast intake would be a function of whatever you're comparing it to. If you're comparing it to an LS4 intake manifold, it's going to be 70 horsepower or more. Or if you're comparing it to a Trailblazer SS or an LS1 or regular truck manifold, and then the motor that you're using to compare it on. On the 6-liter, we saw a big power jump from either one of those, way more than 14 horsepower. So you need to take all that into consideration. That's right. How much boost? You like that? I'm glad somebody caught that. So Utah, you put the numbers in the camshaft calculator and tells you how much overlap, and that's how you choose your cam based on overlap. Help Hot Rod Garage with their 3.8 liter. I'd love to do some stuff with those guys. I like Lucky and Tony. I think that those are good. They're good guys. Oh, Punk's in the house. What's up? I'm able to log on from my room. I have a question on wiring harness and engine management. So I'm running a 4L70 trans. Should I just have my stock ECU flash? Somebody answer him because I have no idea about the factory ECUs. Is the 303 cam a turbo cam or a nitrous cam? Yes, it is those. Vizard says throw the 303 cam in the trash can. Ask David, and I love David because he does lots of cool stuff and he's doing those heads. But I don't have any problem giving David a hard time and calling him out. Ask David if he knows how many B303 cams they sold that Ford Racing sold. I think the number, the last estimate was a bajillion. So how much ever that is. I know what a camshaft calculator does. My question is, do you use just the overlap number to choose the camshaft? Because that's just a weird way to choose a cam. That's what I'm asking. That's what I want to know, how you choose your camshaft. Any chance you will run an MSD 6AL2 programmable on a carb application? We run a 6AL every time we run a carbureted motor, almost every time. They have a grid and stuff too, but I always run the 6AL. And or we won a digital 7, I think, on there also. And so we can program the curve, and especially with when we run carbureted LS stuff, we can program the timing curve. Would a Big Bang 6-liter 5.3 differ much from a Big Bang LS1? Yeah, it would differ greatly, I think, because the Big Bang LS1 has an aluminum block with a thin sleeve, and I don't think it would get anywhere near what we do with the iron block stuff, or with an L33 or LC9 aluminum 5.3 block. But I've never tried it. We don't normally run the aluminum motors much over 1,000 horsepower, except for the ones that I just mentioned. So your stock bottom end 306 had a TVS on it and 100 TVS. You guys like that? And it made 330 wheel horsepower with a TVS. Nice. I don't know what you're saying. So when Fast advertises that it's just more of an actual engineering function of the whole assembly, whatever you test anything on, whether we test a camshaft or an intake manifold or cylinder heads, the thing that you test it on is going to determine what the power gains are. If you test something on a stock 4.8, like if you put a fast manifold on an otherwise stock 4.8, you're not going to get very much of a gain. Not because the manifold doesn't work, but because you don't have enough motor on it to take advantage of what that intake manifold can do. So when you run it on a motor, like I said, on that 600 horsepower 6-liter, the Fast gained a lot of power because now it has enough motor to go, hey, look, I can take advantage of what that intake has to do. The intake manifold, in the case of the Fast and everything else that we test, it's also not just flow. It's not that the 4.8 doesn't need to draw enough air, because the intake manifold is also improving power based on cylinder filling. So it has a supercharging effect based on a number of different things that it does. 3 primarily, the reflected wave, the inertial ram, and Helmholtz resonance. So it has things that are designed into the design of the intake manifold that help it provide a supercharging effect. And it does that differently than other manifolds do. What is the recommended stall for a 6-liter cam in 7875? The turbo, if you have it spool early enough, will change the stall speed of the converter that you put in it. Because the more power you put to the converter, the higher the stall speed is going to be. I don't know what 6-liter you have, and I don't know what cam you have, and I don't know what car or vehicle it has. The cam is going to play a big part on that. So if you have a really big cam, you're going to need to move the stall speed up because the cam is going to be soft down low. And if the cam is soft down low and you have that size turbo, 6-liter is going to help you, but you might not spool the turbo also, so you have a double problem there. Demon Tech, thank you very much. Sorry we have to go, my job. Play with trains. All right, man. Be safe out there on the trains. Almost done with my LS4 swapped Integra. That's interesting. I think it's missing push rods, low short travel lifters, and CV shafts. Yeah, definitely keep me posted, man. I'd like to see that. I've not done any. Well, I've done some work on Ford FE engines. I've swapped intake manifolds and stuff. We ran a comparison. What am I locked into under here? We ran a comparison test on an all aluminum 480-inch motor. So I think it was Robert Pond did it, and we compared a carbureted intake manifold versus like a stack injection thing, and obviously the stack injection did very well, and it looked awesome. This is something I want to see how to program, what the aftermarket ECU or PWM kits work. Overlap is a term we use a lot on rotaries when porting. It's equivalent to swapping cam. Yeah, that's kind of cool stuff on the rotaries. Gotta have the chop. 285 at 50 would have the chop. Yeah, but Dan, what LSA is that though? With Bosch 210-pound injectors, you can turn the base fuel pressure up to 100 pounds and run them on methanol. I would think with 210s, you wouldn't even need to run 100 pounds to run on methanol. They flow a lot. I actually have a B303. I think we have all the letter cams, the old original letter cams at Westech. They've been sitting up there since I ran the test. And I'm sure I ran that test. It's got to be 20 years ago. It has to be. It might even be more than that, because I know that they don't have that data on their current computers for their dynos. so it's fallen by the wayside. And it was back when I was taking pictures with a non-digital camera. It was with film. Tiny 170 TFS head 306 made more power than your 200 cc heads. I don't know who that's directed at. And the thing about having the rotary and having the putting the big cam port in it, they're really, really loud. Dominic, you would gain power going to the 232, 234 cam from your 216, 224. But if you haven't bought that cam, you should pick a better cam. A 232, 234, you're not going to be too happy with. You need a 232, 248. Why don't you watch the Visor video? I watch David's stuff all the time. I talk to David. I know David. I remember you doing something with the B303 way back in the day. I thought I ran all of them. I need to go, man, it's been a long time. I know we ran the stock cam, the stock stick cam. We ran the B303, we ran an E303. I don't know if the F and the X, and I don't even remember. This might have even been before a lot of those are out, but we did 8 camshafts in one day, which I thought was a lot because we were running it with a factory ECU, and we were also running with all the front accessories on it because we had the whole serpentine system. We didn't have a Mazir electric pump back then for the 5-liter. This was the 5-liter out of my Mustang, and so we ran all of this stuff. And honestly, we may not have even had an air fuel meter back then. We may have been doing it by brake specific and looking at the plugs, kind of the old school way. So Mike, you're having a competition now with me on a test engine that I built compared to some engine that you raced back in the day. That's not a good idea. Torque is work and horsepower is work over time. Valve springs do cost horsepower. I did a valve spring test, and you have to be real precise in what you're doing in your repeatability to get the measurement. But I did a test of stock springs on an LS, and then beehive springs, and then dual springs. And as you might imagine, as you go up in spring rate, it does cost power. But again, like Dan said, the choice is that you don't have them and you don't lose that power, but then you can't put any camshafts in it because you don't have any valve spring. Yes, unless it's a Ducati. Let's see. What's the Fig Newton meters you speak of? It could be Fig Newton, Cam Newton, Olivia Newton. There's lots of them. Why did you recommend more exhaust for Dominic? Because it will make more power. You just hit a Holiday Express. That counts, right? And if you wear the train hat, then you are indeed, I've got something on my shirt here. If you wear a train hat, then you are actually indeed an engineer. Wop, wop, wop. What do you think about a B303 cam? I don't really like it. He has spoken. Hey, good luck on your surgery, man. Sign back in and let us know. Any books that you recommend? Yes, read all of the books written by this guy named Richard Holdner. So he can get those royalty checks that come in for, like, some of them are as much as $3 or $4. How often do you change springs on your 600 lift camshafts? I don't ever change them. We put the springs in and then we run it on the dyno. What would be the ideal cam lobe separation angle for high RPM range above 7,500? That's not a thing. You need to look at the valve events to make the thing run up there. And then also, even well, every bit as important as the valve events in the camshaft, you need to look at the stability of the cam to make power above 7,500, at least on an LS. Well, on any motor, really. The B303 is a legendary camshaft. It's like the B303 really, for the small block Fords, is the Duntov 3030 cam of the small block Ford, of the 5-liter Ford. So it's the most famous cam of any 5-liter cam by far. Just like the Duntov cam. You're talking about a Chevy, small block Chevy, the Duntov cam is really the thing. Even though I think Chevy actually sold more L79 cams than they sold Duntov cams, but everyone remembers the Duntov name and the Duntov cam. So when you talk about small block Chevys, I think that's the cam that they would talk about. But I think Chevy actually sold more of the 350 horse 327 cams, but that's not the one that they remember. And if you talk to somebody, an OG guy, about about 5-liter performance, that wouldn't really be the cam that you would pick. Lots of people had them in their cars and they're racing them, but that wouldn't be the best cam to make the best power, as we showed in the dyno results way back then. But it is the most famous, and I'm certain that they sold more of those than anything else. And what's the biggest cam you can run on a small Chevy OEM roller lifters? That's not the limitation. Your limitation is going to be something else. Twin 6762s with a 0.83 AR and a 5.3. Yeah, depending on your cam and intake choice, you can make them responsive. I hate when people ask questions and say, "What are your thoughts?" I'm familiar with Gale Banks' mass air density measurement, and it's very effective. The problem is he's trying to sell you something that shows that. He's trying to sell you a gauge that measures that. It's really good if you have all of that data. But if you're selling that to people that haven't compared NA motors to boosted motors yet and are doing information based on the boost gauge, if they're not there yet, they're not going to be interested in that. And they're not going to understand that. Guys at higher levels definitely will. There's no update on the 2.2 right now. I haven't got the motor back. And actually, there was a Duntov cam and a 3030 cam, and a lot of people don't know those are different cams. I read a thing by Jeff Smith, which was excellent, and I didn't know it either until I read, Jeff is a legend. How much horsepower will an LR4 4.8 liter with FBO and boost for daily on a safe tune? What's FBO? How about a 750 CFM carb test, a Holloway, an Edelbrock, and a Q-Jet? The problem is getting them all on the same intake manifold. Duntov, he was the Corvette engineer. Did he wear an engineer's cap? I would hope that he did. So mileage-wise, what's a good measurement? Because I heard 600 lift cam springs don't last as long. How do you check? The spring, you're worried about opening and closing the spring, like the cycle life of the spring because of the lift. Obviously, look at the factory stuff. They run sub 500 lift things in their trucks, and then they went up to the 550 lift stuff in some of their trucks with a different spring. But they also pay a really close attention to how the ramp rate of the cams, and that will help determine not only how long the cam lasts, but how long the springs last. But I don't think you see too many factory 600 lift OEM applications, because it certainly should hurt spring life. But I've never changed them. Making a cross ram IBT, is it ITB top for my tunnel ram? Going to show car shows and have that 305. Gale Banks is a legend. He knows a lot of stuff, and he's done a lot of very, very cool stuff. Some stuff that he can't even talk about because it's like top secret military stuff. But he does a lot of cool stuff. It's just that Gale is not the go to the wrecking yard and get a motor and put a turbo on it and see what happens kind of guy. He's at a much higher level, and so it's a different thing. Mass air density, isn't that just a calculation, pressure, temperature, and and humidity? And see, when I talked to Gale about that, and they were trying to get me to extol the virtues of that, basically, and which is a good idea. It's good stuff. But then I asked him, I said, well, doesn't a mass air meter and a boost gauge tell you that? And he said, oh no, it's completely different. What is the boost and possible power potential twin BorgWarner 66 with a 0.9 AR and a 383 small block Chevy? I don't know what 66s you have, but it's going to be 4-digit stuff is the potential of those turbos. I want to boost my 4.8 liter LR4, but trying to see what the stock bottom end will hold for a daily driver with boost. Go take a look at the Big Bang motor. We ran 70 poles at over 1,000 horsepower. So you can easily make that. If you put ring gap in it and you put, head studs and head gaskets in as your daily driver and tune it properly, it will run like 600-700 horsepower. It'll run that indefinitely. What do you think about the Summit Stage 2 high lift with the T4 on a 5.3? I don't know what the specs are on really any of the Summit stuff, so it's hard for me to say. I have tested a couple of their cams, and all of the ones I've tested have worked very well. But and I would look at if you're running, I don't know what T4 you're running, because there's about a bajillion cams that are T4s. What size T4 is it, and what is it you want it to do? Really, the upshot of all this is you just tell me what kind of power you want, and I'll tell you what camshaft you should use on your 5.3 and what turbo you should use. And usually my recommendation for camshaft tends to be on the small side. And David, ask your question one time, otherwise you're gone. I have a 350 small block Chevy, 40 over flat top, 2V release with dart iron heads, 510 lift. Will the sock roller lifters hold up? The roller, if it's a hydraulic roller cam and you have hydraulic roller lifters, that they won't care about that lift. I don't think you see all the comments. I do see all the comments. Try to read them all. Sometimes I can't answer them all if a lot of them come by at one time. NSR cam test for LS, then we find out if they make killer torque and horsepower for less work. I've run lots of those things for Brian Tooley, and there is a difference between an NSR cam and like a 500 lift cam and a 550 lift cam. There is a little bit of a difference in power. I don't know how you do I don't know how you do a longevity test. How do you size the turbo? You size the turbo based on the power needs. So if you want to make 1,000 horsepower, the first thing you do is pick 1,000 horsepower turbo. And then you pick the rest of the combination to go with to make that turbo work. Thanks for replying to me about Bill saying the timing needed to be 40 degrees because of the cam. Yeah, that's not really cam related. Do you have a rule of thumb for the amount of duration difference with a dual pattern cam? I don't have a fixed amount. I just know a lot of the cams that I've run, and I can tell you what they do. Yeah, David, there's no reason if you ask a question, I'll try to answer it. I try to answer all the questions. I would think cam specs from 50 or 60 years ago are obsolete. Probably. They're not obsolete. They still work, and they still made power back then. But there are different ones now. Richard, when comparing flat tappet cam durations at 50, do the solid grinds have less than advertised? They have less than advertised lift because of the loss in lash, because from a solid roller or a a solid flat tap at either one, and the duration is going to suffer a little bit depending on how much lash you put in there. Richard, LS1 air lid and long tubes, looking to get an LSXR manifold. What cam would be a good match? Tell me how much driving. You don't drive in the city for drivability. If you want lots of power, the biggest cam you can put in there is like that Comp 469 camshaft. That one will make good power in a 5.7. But I think for that, if I was driving it around, I might pick a 54-454-11 cam, which is a 227 cam. That one works pretty good. And when I recommend that cam or the 469 cam, there's others that are like that, from lots of good stuff from Cam Motion, Brian Tooley, and other ones from Comp and Texas Speed. And everybody has cams that are like that. So if it has specs like that, it's going to work like that. Duration specs also depend on the cylinder head being used. Some engines use reverse pattern cams. I would like to see a reverse pattern cam actually work on something. Other than the one exception that I see are 4-valve heads. They seem to work for those. Richmond's Garage here is in the house. Nice. What determines the RPM limit of the hydraulic roller? The roller doesn't really do that. The weight of the roller does a little bit, but the RPM limitation of a hydraulic roller setup is usually the stability of the camshaft. So you have to have a camshaft that wants to run, its frequency wants to run in that RPM range. So whatever that is, they have hydraulic roller stuff that runs 8,500. And probably more than that. But once you get up there, the solid stuff is kind of the way to go. But so it's the weight and then the control. And a lot of the control is not done with just more spring rate. A lot of guys think that, oh, well, it's a heavy hydraulic roller, so I just need to add spring rate to it. No, a lot of times spring rate like exaggerates the problem. So that's why they use spintrons to find out what's happening with loft, what's happening with bounce, what's happening with the control. And then sometimes, like I said, if you, well, yeah, we're going to overspring it. Then we're going to crush all that. We're going to make it do what we want it to do. It doesn't do that. It makes it worse. Have you tested cams for power up to 7,500? Yes, we run LS motors at 7,500 all the time. GRW should be on the box. I don't know what that is. Richmond's Garage. Oh, you had COVID this week and didn't feel like doing anything, just got over it. Yeah, I would imagine you feel terrible. I've heard that it's not good. I've been on here more than an hour. I got to get going. Work on a stock 5.3, 706, tick 23, 223, 227, 621, 600, 114 plus 3, 78, 75, VS Racing, and all the boosts. If you're going to run a lot of boosts, then you could get away with a cam like that. For a 78, 75 Gen 2 VS Racing turbo, you don't need that much camshaft in a 5.3. You can run a lot less than that. But that cam will certainly top out that turbo. Are the lightest parts possible in the valve train the best way to maintain control? No, that's another myth. That helps with RPM. It can help with RPM. But sometimes, again, it's a frequency thing. A lot of people don't realize that when you excite something, this is how Helmholtz resonance works. When you excite something, it vibrates at a certain frequency. And when all those frequencies aren't matched and they're counteracting each other, it's not just, this is like flow. This is like the flow conversation all over again. Sometimes lightweight stuff helps. Sometimes it doesn't. Brian was telling me about an interesting test, and probably we'll talk about this on a live, on an interview that I'm going to do with him, an interview video. But going from a titanium retainer to a steel retainer actually improved engine speed, improved RPM. It made the thing more stable. And so even though it had more weight, it's not a lot on an LS. That's the thing, because the retainer is so small, you don't get a big change in weight going to titanium. But the titanium was moving around a little bit more than the steel was. So it was better having the weight. Yeah. David, I don't know what T4 yet. If you're looking for 500 wheel horsepower, you have a 5.3. You should that 218, 227 cam will work fine. There's lots of other smaller ones that will also work. I would probably pick a smaller cam than that. Like if you look at the Truck Norris cam or any of the Stage 1 style truck cams, and then put a GT45 turbo on it, you can easily do that. As a matter of fact, with a stock cam, you can make 500 wheel horsepower pretty easy with just the stock cam and boost. Oh, Cameron, I bought a solid roller today, or a solid something. 242. You're not gonna. I don't think you lose anywhere near 10 degrees of duration with going from a hydraulic to a solid. I don't think it's that much. Any idea where to look for Chrysler 2.2 turbo headers or better intakes? The somebody tell me the name of the. I think there's a place in Arizona that does. I have their exhaust manifold on the 2.5 liter, and I can't remember the name of it. That has 2.2 headers for it. And they're not headers really. It's a cast manifold, but it's better than the factory one. And honestly, I haven't yet found out how much we can make from the stock one. We might be able to make a lot from the factory one, because if you get all the exhaust to the turbo, as I say, good things happen. But I will be trying I'm going to be trying probably an adjustable intake manifold. I got a guy that's sending me a flange, I think, that he made. So I'm going to hopefully buy that from him. And then I can make standoffs and make all that stuff and make it adjustable and double wazoo Super Richie throwdown. When would you do an inline 6 Jeep engine? That would be kind of cool, but I don't know when. .2 LT in a truck, which cam, you can make a lot with this cam that's in that. That thing already makes a lot of power. But Brian Tooley has a lot of really good. He has a 220 cam for the LT stuff that makes a lot of power. Okay, I can't stay on here forever. I've been on here a long time. Thank you guys all for showing up and putting up with me for another night. Hopefully you guys have all taken a look at the video that I have up on the what has to be the least powerful LS intake manifold I have ever tested. That poor little LS4. But as I said in the video, it's an opportunity for somebody to make a manifold and hopefully make a bajillion horsepower. Thank you guys all for showing up. I will see you all tomorrow. Do, 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 do. Do, 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 do.